Hello, everyone. Welcome to our webinar, Building a Better Future from Yesterday's Waste, and thank you for joining us. My name is Heather Nelson, and I'll be serving as your moderator for today's webinar. And today we'll be talking about what some people call garbage, our single-use culture, its environmental impacts, and what we can do about it. You'll be hearing a presentation from a series of industry experts on this very timely subject. But before we get going, I just want to take a few minutes of your time for some housekeeping matters. So first, it is the goal of PLAEX to provide you with an interactive and rewarding learning experience. Therefore, there will be an opportunity for you to ask questions throughout this session. All you must do is type your question into the webinar chat box facility on your screen at any time, and the experts will provide answers at the end of the session in a live Q&A dialogue. Also, throughout the session, we will have some multiple choice polling questions. Please answer these questions to the best of your ability, and we will feed back the results of the group. You should also know that this webinar session will be recorded and made available for all participants and registrants to freely access on the PLAEX website. And lastly, I would like to thank our partners for their participation and support. So now, moving along to our session, I am pleased to pass the mic off to Dustin Bowers, who is the product developer and founder of PLAEX Building Systems. In addition to leading today's webinar, Dustin will kick things off by giving you some background on what inspired him to develop PLAEX bricks and why we are here today. So welcome, Dustin.
Hey, ladies and gentlemen, thank you for joining us today. And I'll take a moment out of your busy schedules to learn more about PLAEX Building Systems and the problem that we're solving. I've been involved in the construction industry for over 18 years. I've been involved in everything from foundation to finish. I was inspired to get involved in the construction industry by my grandfather and my uncle, who are both amazing tradesmen. Over the years being involved in the construction industry, it became more and more apparent to me the issues around waste. Every job site, there was bin after bin after bin of discarded building materials, things that were potentially could have been used, resources that could have been made use of, but weren't. Finally, I decided that I needed to start taking some actions. So I converted my 7.3 diesel vehicle to run on waste vegetable oil. And I did that about 2012. So we got about 9 years running now, and it's an amazing way to go. But it wasn't enough. When I finally had my first child, I was inspired to actually take a bigger step. I had seen a research paper about taking plastic and putting it into Portland cement as an aggregate. I decided that maybe there was a better way. What if we took and flipped that model? And so PLAEX Building Systems was born. The design's gone through several iterations, and we've done lots of testing to come up with the most durable solution, but we now have a durable, scalable, highly versatile solution made of over 90% recycled materials, and it eliminates waste on the job site while we're doing that. We're streamlining everything and making it simple, straightforward, and environmentally friendly. Today, we're going to be sharing the problems, which is why we do what we do, and how you can get involved. So just to give you guys an idea of what we're going to be covering today, we're going to be looking at what the problems are facing waste today in our oceans, in construction, and in general. And we're going to look at what is being done to reduce pollution in our oceans, in construction, and in general. And what our solution is and how it impacts these three areas. We're going to show you a step-by-step guide for its uses and installation. You'll learn exactly what you need to do to get involved and make an impact on waste. By the end of our time today, we hope you'll have a solid understanding of the problems that we're trying to solve, and you'll fall in love with our solution as much as we have. We are all about building a better future, and we want to use all of this waste that we've created to build that better future. Join us as we try to solve this huge problem. So let's jump right in. But for our first speaker, we have a couple of skill testing questions for everyone. First off, how many tons of plastic do you think end up in our oceans every year? Next, how much ocean plastic comes from the land?
Okay, thank you, Dustin, for that overview. Our next speaker is James Middleton, who is one of the founders of Ocean Legacy. James has been involved in plastic recycling and the ocean plastic reclamation industry for the past 6 years and has a vast network of global connections with projects in BC, Panama, and elsewhere. James, his partner Chloe, and his team do amazing work facilitating the cleanup and restoration of our oceans and beaches. They're dedicated to making this world a better place, and I want you all to give him a warm welcome.
Hi.
Hi, James.
How's it going?
Good. So I think Dustin's going to hop on and do a quick Q&A with you.
I'm here, ready to share.
Dustin, are you there?
Do you want me to answer the how many tons of plastic end up in the ocean?
Yeah. Do you want to share the answer with everyone?
No, let's see. It's really hard answer. Even the answer that's known to be right or right-ish, I would say that it's likely, well, I know it's exponentially increasing every day, every year. So there is sort of a relative figure that we can figure out with how much plastic is in our average waste output as humans, into our landfills. But that changes from the different type of countries that everyone lives in, how their recycling infrastructure is designed and how well it operates. So yeah, it's a tough one to answer because how much ocean plastic comes from land, that changes dramatically from Canada to America to Panama to Asia, Vietnam, Japan. It depends on what events happen. How much ocean plastic came from land during the Japanese tsunami? A lot. That's how we started.
Yeah, it's a huge problem. So why don't you take a second to tell our viewers here a little bit more about what you do?
Well, yeah, so in 2011, just to tie right into that Japanese tsunami, we saw how much material was coming on to our coastline after the tsunami almost instantaneously. It took like 6 months for some of the polystyrene material to start washing up on shores, and it was a couple of years of seeing that and trying to think about how we could help deal with the situation. My partner Chloe and I, with her background and skill set and my background and skill set, we decided to try and tackle the pollution problem that was washing up on our shores. It brought light to the issue, but since we've been operating as the Ocean Legacy Foundation since 2013, we've seen that the problem was much bigger than just the material that came over from the tsunami. So yeah, we started off just going out with some volunteers, friends of ours, to go and camp out and collect all this material that had been washing up on the shorelines. We started in a place called Muquin Brooks Peninsula on the northwest side of Vancouver Island. Very remote area, boat access only. Beautiful, very beautiful place. It's pretty wild. The last town nearby is a boat access only town called Cayuquit. So we met a local there, Luke Osinenko, who yeah, he invited us out, and we said, okay, let's go see what's going on there. And we ended up pulling out, quite a bit of material and going back there year after year and seeing it, just the amount of material just kept washing up every day. We'd go clean a beach and there'd be more material there next morning. So that was the beginning of us trying to figure out what to do with the material afterwards. And that's evolved dramatically over the years, because we were pretty stubborn with the material that we were finding. We didn't want to just put it into the landfill. Kind of saw that there's a need for the material to be viewed differently, as it's had a lot of handling. It's a lot of efforts gone into creating any type of material that we have on this planet. Anything we touch inherently has the value of our labor associated to it. So just throwing this stuff away and forgetting about it as just
So I've always thought burning it was a horrible solution.
Yeah, so where we've gone with it is basically try and recycle it. Plastic to oil was one of the first solutions that we were really vested in and working on, and that's still a really amazing solution for a lot of material, especially a lot of the heavily soiled material that we find. But we've switched gears a little bit over the last few years, and we've been working on plastic to plastic recycling. And the facility behind me here is our warehouse, an 8,000 square foot facility that basically focuses on the hard plastics, so high density polyethylene, polypropylene, a lot of polypropylene line. And we've amalgamated being able to basically take all the beach cleanups, all the nonprofits, all the local efforts, the industrial efforts to do large scale beach cleanups, and have all that stuff come into one facility and be able to sort and separate everything into its different categories. And we have well over 30 categories of materials that we find, from tires, styrofoam, there's batteries, some metal, glass. But we've really
Doing it.
Pardon me?
You ever come across an animal you save while doing it?
Animals? Yeah. We,
Around any like like that.
yeah, well, so we've done not only work in British Columbia, but also down in Panama and Mexico and Costa Rica. We did a pretty large scale cleanup in Panama where we were in the Las Perlas Islands, which is on the Pacific coast down there, just 60 miles out from Panama City. And we were on an island. There's no inhabitants on it. It's just they're pretty sandy coral based islands. And someone actually found a living leatherback turtle inside of a plastic water bottle. It was one of our friends there, Susan Anders. She's the wife of Manuel Anders, who was the reason we went down there. He's the president of Nestle Waters Latin America, basically the Caribbean, Central America, and South America. So they were helping us clean these beaches, and they were up in the grass and found a plastic water bottle with a living turtle in it, and she actually filmed opening it up. It was like finding a ship in a bottle kind of thing. But yeah, the turtle survived, and it was a good story for sure. It was pretty amazing to see. It's kind of crazy just think of how the turtle even got in there. We weren't even sure how that was possible, because when turtles hatch out of their eggs, they're basically that big. You know, they're the size of that egg. And yeah, that was pretty amazing. But yeah, it happens, but we don't find as many animals trapped as you'd think. Like we have come across it, but yeah, it's like a lot of other animals will eat anything else that's dead. So, you know, if something dies, the ocean's basically a giant carnivore. So, you know, it's chance whether you can come across. But we definitely find lots of floats that have been eaten by creatures of all sizes. There's, you know, styrofoam blocks that have, I'm sure you've seen logs with holes all the way riddled through it from some like woodworms that eat. And those same creatures are eating the styrofoam, and their excrement is comprised of styrofoam, and they seem to be sustaining themselves on it somehow. And you know, we'll find fish eating the foam blocks. We'll find geese eating it. You know, people, all kinds of creatures undoubtedly are filling their guts, and they're asphyxiating themselves from consuming all that. But there's something even worse than the material that we can see. It's how plastic breaks down. It photodegrades, and it starts turning into the microplastic, and then past the micro you can still kind of see, you know, something smaller than a centimeter. But then it starts getting into the nano, and the nanoplastics are, you know, those little tiny microscopic hydrogen and carbon molecules, and so if it's PVC, chlorine, and that's starting to. My partner Chloe's just finished writing a paper for her master's on how the nanoparticles are breaking through the cell membrane, the blood membrane on a cellular level. So it's like everything on this planet right now is just riddled with our crap.
We need to create value out of this material so it stops going into the environment. We need circular economies.
Well, yeah, it's full scale for sure. You know, whatever we do here needs to be done.
I'm curious, in your opinion, what do you think some of the biggest things people can do themselves at home to try and prevent this issue?
Well, right on that topic, I think easiest thing at home is to set up, if you have a water filtration system for your water coming in, because you care about the water quality coming into your home and into your body as you drink it. You can have the equal care for your output off the back end of your laundry machine, for sure, is the easiest. The Vancouver Aquarium out here is also known as, they also have the scientific research department known as Oceanwise, which has a broad look at the sustainability of fisheries and you know, fish caught, and you know, is it ocean wise? And you'll see a little label in restaurants beside some of the meals and fish caught, or you know, prawns or crab or anything. They'll put a stamp, and it's kind of a certification as to how sustainable that product is. They also did a bunch of great research on setting up the water filtration systems on the back end of your washing machine, because you know, everything we're wearing, everything everywhere is polymer based. You know, it's plastic, and so all these fibers, they go out and they do water samples anywhere they want, and they're finding the fibers, they're finding microplastics, nanoplastics. So if you get a really good, just 5 micron, 10 micron water filter, ceramic water filter on the back end of your water output, you can capture a lot of that material. So that's the
Great idea.
I think that's one of the most inexpensive, low cost ways that we could make an impact in the general public, everyone's laundry facilities, and then and then you have to maintain it, but that's not too hard. Turn the water off, unscrew it, look at it. It might be, people think things are tougher than they are, and they just don't do them. They stop. It's like, I don't know about it. I can't alter my regular way of being, but it's not. Life doesn't work like that. You just gotta get your hands dirty and have a look at what the issues are and try and be a part of the change and solution.
Absolutely. Absolutely. Thank you so much. I'm so glad you're doing what you are to help be part of that change. I'm inspired by your work and the things that you do. It's always exciting to see the new stuff that you're working on and getting going out there. Thank you so much for taking some time. If you'll be sticking around to the end here, we'll open up for some Q&A at the end. If anybody has any questions for James, please type them in the message box there. So thank you so much for your time today.
I know, I told you I talk a lot.
Hey, it's good. There's a lot to talk about on this issue. There's so much to talk about on this issue.
Well, you guys, if you want more, there's all kinds of things with our EPIC program and academy. There's a whole program that people can actually take online, and right now it's designed to be free, but it's basically a university program that people can learn more about the education policy practices. It's available in English, Spanish, and French right now, and we're looking to put it into more languages just as more funding becomes available. So check out oceanlegacy.ca, and yeah, you can contact us anytime. We're here to help.
Thank you so much.
You bet. I'll turn my camera off if that's needed. Cheers.
Cheers.
Okay, awesome. Thank you, James. Justin, did you want to do a few more polling questions before I introduce our next speaker?
Well, I can give everybody a quick little blurb to the answer of those questions there. So earlier we asked how many tons of plastic end up in the ocean every year. Now, as James said, that is a very subjective question, but the number that is given is around 8 or at least 8 million tons, which is huge. And apparently about 80% of that comes directly from the land. That's globally. Region to region, things are a little different, but yeah. So next up, we wanted to do a little cap here. So we've got a couple of questions for you. How many tons of construction waste per year do you think are projected to be created by 2025? And secondly, how much of that do you think is recycled? Because construction and demolition materials are wide-ranging, wood and concrete, brick and beyond, it's difficult to sort through and often builds up. While not every piece of debris can be recycled, much of it should be. And it's estimated that C&D materials take up over 4,300 acres at a depth of 50 feet, resulting in over 3 billion square yards of landfill every year. This isn't just bad for the environment. All of that waste is incredibly difficult for builders to manage efficiently and affordably. And quite frankly, it's just wasteful. We can do better. It's time to change how we do things. So stay tuned here to learn some more about construction, demolition waste, and how we can do better.
Okay, thank you, Justin. I'll let you launch those questions and people can start inputting their answers while I'm doing our next intro. So up next, we have Ziggy Last. Ziggy has over 35 years of experience in the construction industry, from concrete foundations to home renovations and nearly every facet of commercial and residential construction. So we're really lucky to have Ziggy here today. Currently, Ziggy is the Ontario Operations Manager for Stowe Canada. So welcome, Ziggy. All right, so while we're waiting for Ziggy to join, it looks like everyone's inputting their answers, which is great. I think Dustin will go over the answers after our next interview session.
I did turn my camera on, but we're just waiting for it to load, I guess.
Okay, yeah, we can hear you, Ziggy. So yeah, we can go ahead and get started, Dustin.
Oh, there I am.
Hey, Ziggy, thank you so much
Good
for
day. How's
taking
everybody?
the time out of your busy schedule to.
How you doing, Dustin? Oh, my pleasure. It's an honor to be here to give you a hand and talk about something that I'm fully believing in as well.
Thank you, thank you. So, how many years have you been involved in the construction industry, and what areas have you worked in?
That's a pretty broad question. I've been in the construction field in many facets, probably over 35 years, actually at least over 35 years. I know I don't even look 35 years old, but that's just the way it is. I've done concrete foundations, home renovations, interior, exterior renovations, general contractor, and also in sales and management at building supplies. And now I'm in operations for Stowe Canada, basically the largest stucco company in the world. We do a lot of EIFs and exterior claddings, and another company that is quite dedicated to the green building and taking care of the environment.
Can you tell us about your experiences with construction waste?
That is a very broad question, and I've been to many job sites, including the one I worked at, and then with sales, all the job sites I visited, and then in operations and production and deliveries and whatnot that I've been part of over the years. There is an obnoxious amount of waste on a site, not only from the trades, but also the general contractors and then all the neighbors in the neighborhood throwing their waste into the dumpsters on the job site on top of that. It's not surprising to get a 40-foot container of waste from building one home, and it's obnoxious the amount of waste, and a lot of it is material that can be reutilized or even donated, reused. I've seen 20 sheets of drywall, brand new. They don't want to take it back, so they throw it in the dumpster. Full 2x4s, they just throw them on the ground, and even stucco materials, what we produce and sell, they throw it on the ground and use it to for a landing strip. Instead of walking in the mud, they're walking on EPS foam, and it breaks up, and there's shards of foam blowing all over the neighborhood because they just throw it on the ground. The construction industry as a whole, I think, needs to step up big time in how they manage their use and waste on sites.
Yeah, I know from my experience in the trades, it's been unbelievable the amount of waste from every job site. It makes me sick to the stomach. Even things now too. Now they got these plastic decking, and I was installing that stuff, and you make a big cloud of plastic dust every time you cut it. There's got to be a better way. So what do you think are some of the big reasons so much of that ends up going to waste? And like, what do you think could be done to solve some of that?
Yeah. I think the onus has to go back to even the engineers and architects, and obviously the general contractor on site. They need to have some protocols in place to deal with the exorbitant waste that's from one small thing, much less some of the skyrise projects that are going on that is container after container of waste on a weekly basis. And a lot of it, there's no single stream recycling done on any job sites. Piles of steel studs and or waste materials that actually can't be reutilized. There's no setups for stuff that could be donated to Habitat for Humanity, for example. Some valid causes that can utilize some of this waste, and it's perfectly good materials or perfectly good recyclable products that there's a lot of good recycling programs. I'll say that with caution. There's recycling programs anyways. A lot of them don't recycle the materials. For example, at our place of business, we've set up recycling bins, so we separate our cardboard and glass and plastics, and those are single stream recycling that we do on site, but they won't take any of the shrink wrap, which is a very recyclable product, but that ends up in our waste container. So the onus, you need to get the general contractors, and every piece of the puzzle needs to put a foot forward and proceed with taking care of our planet. And it is something I truly believe in. I even have a recycling program at home, and the kids really balked at it at first, but now they're on board, and we have a larger household. Two from there when the pandemic allows, I guess. But we have less our entire household every 2 weeks. Mind you, we try and reduce our footprint as a household, and if everybody took that little step, and what I saw when you it's not just making a change, it's also being the change.
Absolutely.
Okay.
So have you seen any big changes or trends going on? I mean, you're involved in material sales and have a good idea of that kind of market. Have you seen any major trends going on in the building materials market?
More in the EIFS or stucco in the now. With Stowe, again, it's the greener footprint, and there's LEEDs values from governments that are promoted by the EIFS manufacturers because it's a greener kind of product. But as far as the waste materials, I see a lot of engineers and architects looking at liquid applied air barrier options rather than sheet goods, where you have rolls and rolls and rolls of non-recyclable products. Whereas the liquid applied, you put the lid on the pail when you're done that project and carry it to the next one. It's less waste, it's less landfill. So it's in my specific industry now, that's one of the trends I'm seeing is more care on, it boils down to the bottom dollar. How much is it costing me to have all this waste when I can close the lid on a pail and carry it to the next project? So
well, that's what people are looking for, stuff like that, savings as well.
Yeah. Yeah.
Yeah, sometimes it boggles my mind how some of these companies can still make money while throwing away so many brand new materials.
It is really ridiculous. It's almost obscene.
Yes,
You get
indeed.
some construction projects and they're throwing out, rather than donate, they ordered the wrong windows. They throw them in the dumpster. And instead of donating or recycling, reusing, which is a great motto to try and keep your costs down, keep your waste costs are obnoxious.
Yep.
Even the cost of having a dumpster at your job site, it's not cheap. But then
And it
throwing
shouldn't
away
be.
good,
It shouldn't be.
no, it should be more expensive and
I
make
agree.
recycling a valuable and viable option for people, and which is again ties in great with your company, utilizing basically material that can't be used anywhere else. Utilizing it in the building industry is fantastic.
Yeah. A permanent material for a permanent solution. No more of this
Yep.
temporary materials for temporary throwaway solutions. You can maybe do that, but then let's put it into a permanent solution.
Yeah, agreed.
Thank you so much for your time today, Ziggy. I really appreciate you coming on. It's a pleasure speaking with you. Full disclosure, Ziggy is my uncle, and it's been great having you in here.
Yeah, I'm proud of you, my little nephew, and come a long way.
Thank you.
And,
Thank you.
And you've got my support. Whatever we can do to help, and not only on a personal level, but I really believe in your business. So take that to heart.
Thank you. Thank you. So just a quick little recap there to our questions that I asked earlier. How many tons of construction waste per year are projected to be created by the year 2025? That's not too far away. The answer to that question was 2.2 billion tons. That's an astronomically huge amount. And how much of that is recycled? Well, it's difficult to really get that number because just like the ocean plastic problem, it's differing region to region. But the overall consensus on a global scale is we maybe reach 48% recycling. Some regions have higher, some regions have lower, but we can do a whole lot better than that because 48%, that still leaves over 1 billion metric tons of construction waste a year. It's obscene. It's obscene. So now I'd like to start sharing with you our innovative solution to these problems and much more. Up next, I have a couple of quick questions for you just before we show you our next video. So how much PSI do you think our material, the stuff that our solution, can withstand? Second, do you think a 22 round can make it through our material? Do you think a 32 special can make it through our material? So I'll add these questions now, and we can get all of your replies here. Oh. All right, ladies and gentlemen. So here I have a couple of videos for you to share. Thank you all. I hope you liked that little introduction.
Ladies and gentlemen, thanks for joining us today here. We're going to be doing some product demonstrations. So to start things off, first we have a concrete brick, a traditional clay brick, and one of our PLAEX test bricks. So today here to start things off, I'm going to go at it with a hammer. So we've got here a 20-ounce hammer. Let's see how they hold up. That one, take it first. All right, so here we are with this lovely little concrete brick we have. Let's see how this holds up to this hammer. That is that. Well, that's concrete for you. All right, folks. Next we got clay brick. Forget safety first. Not much better. Let's see what we can do when we get around to our block. Ladies and gentlemen, so what y'all been waiting for. Let's see how these PLAEX bricks hold up. Am I doing anything? I think we're going to need a bigger hammer. The 20-ounce frame hammer is not enough to destroy a PLAEX brick. Let's see if we can do something a little better. Well, it broke. That's a sledgehammer. Let's try again. Folks, I think I might want my house built out of this. So, just as an extra little treat for you guys, as you saw, it's pretty damn tough to destroy this stuff. You wonder how much force does that sledgehammer really have? What would it look like if, well, this is what we got left of our concrete block from the hammer, got hit by a sledgehammer. Or say, what got left over from our clay brick, got hit by a sledgehammer. Well, let's see. Hey, you still have some doubts? The indestructible house. I think the big difference is here, we've now got a fissure running through that. So, it's cracked. We're in. A little bit of chipping. 22 versus PLAEX brick. Fun testing today. I figured out they may not be totally bulletproof, but I'd say that's a hell of a lot better than the concrete held up. This versus this. I mean, what do you want your house built out of? Nothing. There's nothing even there. I didn't know much. Out of it. Out of it. Well, so much for the solid one being tougher. I don't know, folks. I didn't seem that tough to me. Wow, that one was 25. That was fast. Well, we can destroy it. That takes a whole lot more to destroy. And it's still high strength. Amazing.
All right, folks. Now I just want to take a second to introduce you all to the wall system and how the PLAEX bricks go together. So here's a little video about how they assemble. Thank you all. I hope you did that. It's been a lot of fun putting this all together, getting all the testing done. It's a very exciting time. And so we're now scheduled to start lab testing on this material in May. So very exciting moving forward. And very soon we're going to be into production. All right, ladies and gentlemen. So a little recap to the questions that we had asked earlier. As you can see from the movie or from the video, our blocks can reach up to 2,500 PSI which is equivalent to about 15 megapascals, which is industry standard for pressure or for load. Also, the second question, could a 22 bullet make it through a 2-inch brick? The answer is no. It didn't even crack it, just a few little chips out of it. So it's a pretty amazing product. Now, what about a 32? Well, it made it through, but it still held together, and that brick still had structural integrity. And we still have that brick here right now, and it is solid. So now I think if you guys have any questions, you should feel free to put those in now. We are getting a little bit short on the time here, so I think we can move things forward a little bit quicker. If you guys have any questions, please feel free to ask them. I want to give a big shout out to Abhinav for his amazing animation there. Now, if any of you guys have any questions, please feel free to ask them. I will also, if any of you have any interest in this business, I definitely have a lot more in-depth information. We have a lot of projections. We have all of our sales analysis. We have a very in-depth business plan. If anybody's interested, please reach out to me and we'll schedule a time and we will meet and discuss the details of things. We're looking for more partners. We want to create national and global partners to help move this product forward as quickly as possible. We are now also going to be launching our Kickstarter campaign. So stay tuned and help support us. We're going to be bringing this product to market, hopefully by 2022. Right now we're targeting testing. After that testing, we'll be doing a few real world demonstrations, at which point we'll be moving forward with finalizing all of our CSA approval in order to sell it as a product for low-rise construction. Thank you, guys. I think I'll open it up to the questions here now.
We have a couple questions that have come in. So what I'm going to suggest is we go to the questions first, and then for anyone that's able to stay on past the 1 hour mark, if you want to go through some of your slides, give a little bit more background on PLAEX, perhaps we could do that. So I think I'm just going to get to the top questions, which are, people are wondering, is there a specific type of building that PLAEX bricks are most suited to?
Well, PLAEX bricks have been designed for all kinds of low-rise construction. So we're targeting things like flood walls because they can be put up and taken apart again. Amazing. Reusable instead of sandbags might be a great solution. We're also targeting things like retaining walls, foundations, and eventually full wall systems. Our compression values are enough that we should be able to meet standards for any and all low-rise construction.
Okay, perfect. And so then I also was getting the question about cost. So is this material cheaper than a conventional brick, or how does it compare?
Well, when you take in the total build cost, our system is way cheaper because we're reducing the amount of time, the amount of materials, the amount of waste. This is a zero-cut system, so there's no waste if installed correctly. So per unit, they're slightly more expensive than a conventional system like cinder blocks per se. But due to the ease of installation, the lower requirements for labor, it simplifies and makes the entire project much cheaper at the end result of it. We can put up houses with this exponentially quick, and it's also well suited to be integrated with autonomous building systems, which is where we're moving forward in the future. So this system is really set to totally simplify and streamline the entire process, which the cost savings of that are huge.
Okay, awesome. And at this point, just one more question. How and where will the PLAEX bricks be manufactured? So can you give us some information on that?
Well, currently, we're doing our R&D out of this lovely CCAN shop here. So you can see the crazy Mad Max machinery behind me here. We are looking at potentially setting up our production facility in the Moncton Dieppe area in order to be as centralized as possible in the Maritimes. And then we're also looking at partnering with other companies to get regional production going, because one of the big issues with recycling is that it needs to happen locally. So we're going to be developing systems in order to share that technology with partners around the world so we can really scale up quickly and solve this problem.
Okay, fantastic. And for anyone that's still on, feel free to keep putting your questions into the chat box, and we can follow up by email after if we don't have an opportunity to get to them.